Good afternoon, everybody. Good evening, good night, good morning. We'll let a few more people trickle in here. Got a few things on our agenda, not a packed schedule like normal. Lots of things going on. I know I've had a busy week. Had some folks getting back from ETH Denver. I don't know if Morgan's here. I know it's late on that side of the world, but Morgan was out doing crazy things in ETH Denver. Some of our team was there as well. Please link the agenda. Good idea. It's a kind of a rough. We don't, so the dev meetings, unlike the protocol meetings, don't have a Google Doc. Maybe I should start doing that. I can paste this, and then of course you've also got the agenda forum post, which I'll also link. All right. I will do my best to keep an eye on the chat as we go through, and definitely feel free. We don't have any guest speakers scheduled for today, but if you want to jump on stage to ask any questions, definitely feel free to do that. Okay, I'm just going to open this up on my other screen. I'm trying to screen record the one side and make sure I've got my chat open on the other. All right, cool. So the first thing that I wanted to talk about is kind of some work that I've been doing, and I don't know if I honestly don't know if other people are kind of in the same boat, but is this? I hear a couple of people saying the sound is really quiet. I don't know if that's true for a lot of people, that the microphone is very quiet. Don't know if there's a whole lot I can do at this point. Let me make sure my Discord's using the right microphone really quick. Is that any better? Yes or no? Smooth, just quiet. Yes, that is better. Or yes, it's smooth. ASMR. Yeah, if you click on the tile, you're able to turn me up a little bit. I don't know. I feel like this happens occasionally, and I never know exactly what the deal is. I can try adjusting. I've got like these little knobs on my microphone, and sometimes fiddling with those helps. I don't know if I just need to get a new microphone one of these days. But anyway, we'll turn it up in post. You know what? I bet I know exactly what this is. Hold on one second. Sound output. Nope, that's on max. Crazy. Is that any better? That might be better. That might be way better. Yes, way better. All right, my bad. Goodness gracious. Technology. Okay. That only took 6 minutes. So I've been working on cost-driven development. So this is As I've been writing smart contracts, and particularly now that we're on, I don't have my camera on, that might be nice. Particularly as we've been doing, got on a mainnet and we're actually starting to spend real XLM. Cost really matters now, and I've been thinking about it a lot more. And I've spent a bit of time trying to understand fees and metering and where costs come from, and a little bit less on the XLM side. Like the XLM costs, you can only really affect if you understand the limits and the metering, like how many bytes you're writing and the CPU cycles you're using or instructions you're using. So if you can address those issues or those numbers, your XLM costs will of course go down. So yes, those two blog posts that Matthias linked, those are the ones that I've written in regards to this. But I've just been spending a lot of time thinking about this. And in the process of doing that, discovered some quirks or issues, I would say, maybe just nuances with both the simulation environment, the RPC there, and even submission and just some like quirks that I wanted to make people aware of. And we can kind of decide what the priority of either addressing these or even just the tricks I'm using right now to get around those issues. But it's very helpful to know your way around those. At the very least, so that you understand how to address them. And this is not like, there definitely will be contract errors that you hit, but there's kind of like two classes of errors that are on my mind when I think about developing a contract. And the first are like user errors. You don't have enough XLM in your account. You forgot to sign the transaction. There may be ones from the RPC is down. Things that you either really can't address or that your user is going to have to address, or I would consider like wallet level issues, things you really should be passing on to your user. And then there's another class, and that's like the typical class. That's the class that we think about the most in any sort of development. But then there's this other class of error, which is limit-based errors that I don't think we've thought much about. And in typical computer programming, you don't think about them at all. Like you're not, when you're developing on AWS, you're not really concerned so much with, when I make this API call, how many CPU cycles am I going to use up? What's my memory usage? You might think a little bit about like storage costs, but not in the line of like a couple of kilobytes. So this is, or even like bytes. So this is something that is quite foreign to the most developers' workflows. And so I think a lot of folks have not really thought about it. And even in some of our tooling, I'm not sure that we've surfaced it as well as we might. And this is the kind of the next class of errors, things that you really shouldn't be passing on to the users, that you should fix before your contract ever makes it onto mainnet. So this would be all of the limits. There's two documents. If somebody can link those, if you go to the Sorbonne docs and then Command K and search for fees, and then I think there's another one called resource limits and fees. So there's two different articles, and this is going to list out like all of the. I think it's. Let me see if I can find the other one really quick. This is the one that's particularly important. The one with resource limits and fees. This is going to tell you all of the limits for various things when you're developing a smart contract. And so these obviously have some correlation to XLM costs, but it's more just these are the ceilings. And there's a list there for phase 0 and then the phase 1 that we're currently in. And these are low from like a general computer programming, right? They're awesome and there's lots of great things you can do under these limits. But if you're not aware, particularly of things like the read write ledger entries per transaction, where you can read 40 things and write 25 things, the events return value being 8 kilobytes. So if you have events that you're sending in your transaction, or you're calling cross contract calls that are also including events that at some point exceed 8 kilobytes, you're going to get errors. And if you exceed any of these things, you'll get an error. The issue is that the errors right now are a little bit unintuitive, particularly from simulation, where when you run a simulation, it'll say in some cases that there was you exceeded, particularly on something like memory or CPU. But simulation will not error for things like the number of reads and writes. It will let you read and write as much as you want, and then when you actually go to submit, then you're going to run into errors on the submission side. So this is difficult to deal with. There's not like there's like 11, I think I counted, limits that you have to be aware of that you can exceed. But there's just a ton of different errors that you might get depending on how much you exceed, which one you exceeded first. So it kind of becomes this game of whack-a-mole, both on the simulation front, where it may not be telling you much about what you exceeded. It may just say the transaction was malformed, or it may say TX invalid or something like that. Which, okay, thank you, but it may not trickle down all the way to actually helping you figure out when you're developing your contract how to fix it. So you may try and like fiddle around, either bypass simulation or and like write your transaction by hand, which is difficult on its own. Or you might try and simulate with lower limits and then bump up the limits from the footprint that comes back so that you can submit something valid and then get the errors back from submission. Because right now, submission events are where you actually get like the core metric logs. If you look at your transaction when it comes back, there's a transaction meta XDR. You can observe that, look at it, decode it, and get all of the events from that, which is awesome. But you have to get to valid submission, which is again non-trivial and would be really nice if it came from simulation. Because like the whole point simulation exists is because building transactions is kind of difficult. All of that to say, and again, these are errors that hopefully you'll be fixing before you ever get to finishing your contract. Again, if there are, and I don't really see this happening for this reason that it would be really hard to fix. If you did ship your contract and you fixed all these things, and then the network upgraded or updated its limits to something that was smaller, I guess you could end up running into these limits. Hopefully that doesn't happen. But the idea is that these errors you're kind of fixing and resolving in development. And so that's why I mean by like the two different classes of errors, where you've got one set that are errors that you pass on to your user, which we're all relatively familiar with, and then a whole nother set of errors that you really are addressing just during development. And those are the ones that I'm having a little bit more of a time with. The other, so that's like one side. I don't know if anybody has experience there, and I'm willing, if depending on where we have a time, I might actually walk through how I'm addressing that with the Quick Start Unlimited functionality, where you can essentially get all of this information from a Quick Start that doesn't have budget or has astronomically high budget. So you can simulate everything and then just count it and then compare whatever it counted against the limits for whatever network you're on, whether that's mainnet or testnet, futurenet, etc. And if we have time, I can, if people are interested, I'm more than willing to walk through that. But the post also walks through that, the part 2. So that one is an issue. Again, I think it has a way around it. Maybe it's the right way around it. So we can discuss that. I'd be curious if other folks have had experience working with some of these limits and how they're getting around those, or have found simulation to just not be that helpful on errors, or if it's really not that big of a deal. The second piece that I just want to touch on briefly is the TypeScript bindings, because I think there are a few folks that are having issues with this, particularly in regards to debugging contracts during development. TypeScript bindings are amazing. I love them, and I can't wait for them to continue to improve. However, during contract development, and again, this is like this whole flow of, it's a little bit odd when you're developing a contract and then you're building out a dApp that consumes the contract, that you're also kind of developing the contract in the process of building your dApp. It's a little bit foreign of a contract. Usually you build the API and it's really solid, and then you go and you build your client interface on top of it, because you're not running into weird limit issues when you're just doing typical programming. In this one, though, you may build a great contract, but not really be able to measure its limits until you get to the dApp process, and oh wow, I went way over my rights, and I didn't realize that because it was never caught in the Rust side of things, because no error ever threw. And then you go into your dApp, you start building, you hit those errors, and then you've got to go back and fix your contract. And so if you're using the TypeScript bindings while you're debugging, it's just not surfacing things like the events from simulation or submission, which just make, in like this, even like the signing of things can be a little bit tricky. So I've certainly had issues with that. And the problem is then I end up just scrapping the TypeScript bindings and using just the Stellar SDK. And there's not really going to be a point that I have an intention or a plan to like rewind and go back and actually re-implement the TypeScript binding. So I've spoken with Chad and the AHA folks on this, and there's a PR. They're like in the process of this big I don't know if it's a rewrite, but merging the TypeScript bindings, a lot of that code over into the Stellar SDK, and adding a lot of this functionality and just cleaning up the TypeScript bindings generally. I'm gonna paste a link. This is I think, unless Chad, I think you're in here. If that's, I think that's kind of the one to keep an eye on for whenever that gets merged and then pushed live. That's the one that I've definitely got my eye on for improving and kind of doing this big migration. They've been doing a ton of work behind the scenes, improving all this. So it's kind of just let's wait until that goes live, and that should fix a lot of these problems. But I would also say if other people are having struggles with TypeScript bindings, make sure to surface those in the repo, or talk about them here on Discord, because I know when I had posted the agenda, there were a few people that reached out that said they were excited to talk about this because they'd also had issues, which the only note there is make sure if you are that those are getting surfaced so that we're able to improve the TypeScript bindings so that they're the best that they can possibly be. And if Chad, if you wanted to jump on and say anything in regards to that, you're more than welcome to. You definitely don't have to, but want to give you the chance if you had anything to mention on that front, or if anybody had any questions or concerns about the state of the TypeScript bindings. Now would be a good time to talk about those. Chad, I'll pull you up if you there we go.
Hey.
Hey, Chad.
Hello. Yeah, I guess what I would like to add, yes, I am in the process of ripping out a bunch of the TypeScript bindings from the CLI repo and leaning on the changes in the pull request that you linked to there, Tyler. The other thing that I would like to say, and like there's a bunch of good improvements there that you'll see in the pull request description. The other thing that you can do is that NPM, even if you're not using Yarn, you can use workspaces now. I'll document this somewhere, but it works pretty well. So you can add a like packages folder, and then you can add your generated contract clients to that. And you can fork the Stellar SDK and put that in there also, so that your generated clients will be using that local in the workspace version of Stellar SDK. And then anytime there's like something that's frustrating, I think, like, I haven't actually verified this yet, but to me it seems like it would be a lot easier to get right into the source code of your local Stellar SDK and then potentially submit a change to the logic of the binding, or the like, it's not going to be called bindings anymore because it's not the generated stuff. It's the contract client logic within Stellar SDK. So yeah, it will be able to move a lot faster, and I think it'll be a lot easier for anyone here to start submitting improvements to the contract client logic. I think the version that's in that pull request is a pretty strong foundation, and we should see some rapid improvements once that lands.
Yeah, I think so. That's exciting.
Wrong button, but I might be done now.
The only other question that I had, and this is something this is more of an issue that I have with the Stellar SDK. That's it's a very specific issue to deploying on Cloudflare, which is like this pseudo node environment. What you have to do is swap out the Axios library and do like a polyfill of fetch. I guess a polyfill of Axios that uses fetch behind the scenes. And this has always been a little bit of a source of frustration because now I have to update it in the Stellar SDK and use a custom version of that, and I have to update it in the TypeScript bindings like generated library. So I don't think there's probably anything to do right now, but that's definitely something I'll be looking to add myself, is an easier way to swap out some of the Axios logic to make it run in these like pseudo node environments.
I would love someone to just send a pull request that gets rid of Axios from Stellar SDK. So I'm assuming there's like grant money available for someone who wants to go do this. I don't know what all the technical considerations are, but like someone go make it happen.
Yeah, I know the main one for not being able to switch it out to like something like fetch was for and I don't know if George is in here. He could speak more closely to this, but there's a particular section in there that when you're pulling down a TOML file, it has to like observe the amount of like bytes that it's been pulling down, and if it goes above a certain number, it will kill the request, so you don't end up in these like denial of service attacks where somebody just has a massive TOML file that it's pulling down to read. And Fetch doesn't have this ability, or it was tricky to add it or something like that. But I would also like to get rid of Axios. I kind of feel like Axios is the jQuery of HTTP, where we've moved beyond this, but they keep updating Axios, and so people keep using it, and it's like we don't need it anymore. Fetch is everywhere. So we'll see. But yes, that would be amazing if even just like, again, trying to remove dependencies that are normal, but not, they're not everywhere. Like Axios doesn't work in Cloudflare, which is a really popular place to deploy static apps or even dynamic apps. And it doesn't support a lot of node stuff because it's this weird pseudo node environment. However, we do have a way around it. We just have to use an older version of Axios, and they have like an adapter thing that does polyfills with fetch that I guess works.
So that's what you do when you want to deploy to Cloudflare workers.
Yeah, it's a bit
Wow.
of a mess, but it works. I don't know. I don't pull down TOML files that much, so it's a little bit like, can I just turn that feature off and then use fetch? And then if I need TOML files, I can figure out my polyfill. But that may be a question for another time. But first, we just need to get this merged so we can get back to making sure people are using what did you call them? Generated contract clients?
Contract client. Yeah.
Contract
Contract
clients.
client.
Because having a typed contract interface is amazing and it's necessary. And then the other side of it is all of the retry and like submission logic that you have that people are like custom writing. Because, right, you have these two
Right.
simulate and submit. Well, there's like three things I feel like TypeScript or the current bindings do. The one is the interface. The second is adding sanity to actually simulating and submitting, kind of more of a Horizon type experience where it just works. And then the last one is signing things. Signing things is non-trivial, particularly once you go beyond just the basics. But if you have auth entries to sign, it handles that in a pretty beautiful way. Once you decouple it from having the particular wallet, which again that's in there. So once that's in
Right.
there, this becomes an incredibly powerful library outside of what you can already do with the Stellar SDK. Okay.
Yeah.
Yeah, appreciate you jumping on, Chad.
All right.
Appreciate the
I
work you guys
I
are
think
doing.
you can release me now.
Yeah, yes, you are dismissed. I don't know if I can. I don't have to kick you. You can just hang up, right? Or do I have to kick you? That would be a little more. Get off of my
Oh, I can. I can
stage.
abandon the scene.
Wow, that's very aggressive terminology. All right, so that's that. Next up on our agenda here is talking about the phase one fees and just kind of generally how we're feeling about it. So we've got this. Fred from Lightmint built us this really cool dashboard here, though it seems like the axes are getting a little unhelpful as we have so many invocations and not as many uploaded WASMs or created contracts, but lots and lots. I think you guys tell me when you look at that graph, can you tell when people deployed some oracles? I'm guessing somewhere around March 4th. That's just my thought. But that's a cool graph to see the activity on mainnet. But I don't know if anybody had any thoughts or things they wanted to add, concerns they have around phase one limits, things that are holding people back from deploying to mainnet. Have there been any blockers for folks for getting stuff deployed on mainnet? I know for myself, some of it's just waiting, making sure my contract is tuned appropriately. Some of the things that I've been seeing between testnet and mainnet were a little different. I think Robear, I don't know if you're here, had called this out. Noticed that the cost between like testnet and mainnet were a little bit different because of like the ledger size and some odd estimation nuances there. So there was maybe some concern to just like, oh, let's actually make sure we know how much this is going to cost before we publish. But I don't know if anybody has anything else to add there. I'm also going to paste this link. I think, actually, let me, since I'm doing this in Discord, there's a new forum called Mainnet Contracts that we're hoping once you do get something deployed to mainnet, you can post in there so that we're able to better keep an eye on things that have been published to mainnet and help promote and just keep an eye on what different folks have deployed to mainnet. So as people get things on mainnet, make sure to publish. Though I know even like these oracles aren't listed there yet, so we need to cycle or circulate this forum a little bit better. So I'm making you aware of it, so that as you deploy to mainnet, you can list stuff out there. Yeah, I don't know if anybody has any thoughts on that for mainnet. If anybody does have questions or thoughts, feel free to either put them in the chat, or if we want to jump on stage, that is fine as well. Also, I don't know if anybody has plans. I'm eagerly waiting. Moots, I see you in there. When are we gonna get Blend on mainnet? Tick tock, my friend. I don't know if TDEP, he's got one too. Patience. All right. All right. Well, if there is anything, feel free. I think I'm not exactly sure. I know that we're planning for phase two sometime this month. Last I heard. I don't know if there's anything additional on that. I don't keep up too closely. I'm still thinking and working through phase one, but doesn't sound like too many people have hit issues with phase one. Certainly, if there are, feel free to let us know. Dima?
Yeah. So for the phase two, actually, I do have some updates. On the short notice, but I don't think there is anything to prepare for here. I think we actually wanna bump the testnet limits, provider limits to the phase two values that we have modeled so far. And the bottom line is basically that we increase certain relevant limits about 5x, which these limits are instructions, read and write entries, and bytes, or read bytes. So basically, we don't scale the transaction size limit and the total write limit. I don't think this should be a big issue in scaling, at least from what we have observed so far in the mainnet. The network is mostly constrained by the number of entries written, just because yeah, there are oracles and we have really small limits. So this is increased quite a bit. So hopefully, we will be able to get into ledger even if there is some oracle deploy happening now. And yeah, in general, it should be possible to have like about 10 pretty heavy transactions per ledger, or 20, maybe even more lightweight transactions, depending on what you are doing. So yeah, that's a bit of scaling, maybe not like super huge or exciting, but still kind of substantial compared to phase one. Yeah, and we do not touch any transaction limits or fees at this time. So basically, the main effect is that we'll be able to do more stuff in the same ledger. And since we want to do it on the testnet, so if anyone wants to, try to test parallel transaction submission, something like that, go ahead and try that, see how it works. We want to do a little bit of stress test, I guess, this way on the like arbitrary traffic that we cannot come up with ourselves, but also, you probably should try checking how concurrency works in your app, for example, right? If that's an issue at all. So yeah, I guess that's the update.
Awesome. Is there anywhere to keep an eye on what the current recommendation for or proposal for phase 2 limits? Like I know we have this pubnet phase 1 JSON file in the
Yes,
Sorbonne settings.
I have a PR opened. If you want to see the diffs, you will need to manually diff it with phase 1 JSON, which belongs to exactly the same directory.
Sick. Perfect. There you go.
Yeah, so anyone interested may take a look. But as I said, yeah, there are just tweaks or
That's super
white or
helpful.
white limits updated. Yeah.
Cool. Nice. I think that's all on that front. Does anybody have any? I know Moots, you asked that question. Hopefully that PR helps. I'm not seeing anything else in the chat. Anyone have anything else to add to that? Otherwise, I can move on to. Oh, wait, there was a good question that I think it's not even here. Morgan asked that I have no idea what the answer is, but I also think I see Lee in the chat. There was one that Morgan asked. My question is, why can't we query the RPC for TTL of a ledger entry directly using ledger key TTL? The error code is this -32602, and message ledger TTL entries cannot be queried directly. So that was one question. Maybe the second one is related. Also, how does one query for instance ledger values? We currently have this durability enum in the XDR, and if I query for instance ledger key with persistent, I get no results. I don't exactly understand that question myself, but if someone does, Morgan was asking it, and now might be a good time to answer it if somebody knows. Otherwise, you can also answer the question async or ask additional questions. Looks like Moots maybe has an example of reading instance keys.
Yeah, for the instance key reading, to be clear, instance storage is just an API abstraction. The instance entries are just stored in the persistent entry, which is contract instance entry. So for the instance queries, you just need to query the contract instance entry, and you will get the map of all the instance values. As to whether RPC should provide a nicer API that will do a map lookup for you, maybe. Please go ahead and file a feature request against Orban RPC if you think this is something you'd want to see. And as for the TTL question, again, I cannot talk much to the RPC design specifics, but our general intent for the TTL entries to not be user visible. So we don't require you to put them into footprint. We don't count them towards limits for the reads and writes and stuff like that. We do charge some fee, but we don't count for limits. We just charge it from the refundable fee. So we try them to be as invisible as possible, at least it's a core layer. And I guess RPC follows the same philosophy of just trying to not expose the TTL entries directly and just display TTL as a property of the key itself. That said, if for whatever reason you build TTL keys yourself. Again, please feel free to file a feature request against Robot RPC. I think it was just a decision based on the fact that we kind of don't want to explicitly post TTL keys, but if you have a compelling use case where it makes sense to actually build a TTL key instead of like a normal ledger key, sure, I don't think it will be hard to, but again, you probably just need to file a feature request and explain what your use case is.
Yeah, that makes sense. Cool. So Morgan, when you're listening to this in post, feel free to add some clarity on what you're trying to do, and either here in Discord or if you want to file an issue, make sure to do that. Cool. Anything else that anyone wants to raise? Moots, thanks for that link. That's super helpful. I always love to look at blend code. You're a good TypeScripter. I assume you wrote this code. I actually have no idea, but whoever did, good code in there. All right. Well, with the time we have left, I'm going to do a quick workshop around how to use the unlimited quick start to run simulations on your transaction invocations to get a picture, kind of like a snapshot of all of the limits that you're touching. This is the way that I'm doing it. I don't know if this is the way we want to encourage people to do it, but it definitely works. And it's the way I'm measuring my contract costs and then going back and making tweaks. Again, you probably want to read the post for like the why and all the other ways you could do it. But then at the end of the day, this is the way that I've wound up doing it. Let me get some things rearranged here. And then I will share my screen. I actually think I'm going to move. I'm doing a screen recording on this screen. So just in case, I'm going to move this over and then share this guy right here. Okie dokie. This is all very tiny, so let me make it not that. I'm going to make this big, and then I'm going to kill it. I actually already be dead. Yes. Okay, so I've got this repo that's in my KillPale GitHub that I recently published. So feel free to pull this down. It comes linking to this package. Like at the end of the day, the thing that you really want to hold of is this Sorabil tool, which is a very simple tool. This is all it's really doing is just grabbing a hold of a simulation, a successful simulation, and then optionally a successful transaction. And then from those responses, deriving all of the different limits. The ones that I measure against, you've seen that, you've seen that PR that Dima linked to this one here, which, whoops, nope, not that one. Oh, that's for configs for testnet, which is also probably helpful. So it basically grabs all these. Not all of these are, I'm going to say, not relevant for developing a contract. A lot of these, most of these actually have more to do with the correlated cost between your actual invocation limits and what they mean for how much they cost in XLM. The only ones that I really care about are things like byte limits and CPU instructions and memory limits. So I went through and basically just removed anything that I don't think actually really matters from a metering, as you're like tweaking your contract perspective, and narrowed it down to this list, this phase 1 JSON file. So this doesn't actually get used anywhere, but you can see these are the limits that I'm actually considering important, and we'll deliver some response back in the Sorabil response, which we'll get to in a minute, so that you can compare those responses against whatever phase we're currently in or the network that you're executing your actual contracts on. Because the idea is for the method that I use, you actually execute your contracts, simulate them, and submit them against this unlimited quick start, which I think this PR is actually latest now, so I might update that. But regardless, you use this limits unlimited, which basically removes the limits or sets them extremely high on CPU and bytes and memory and etc., so that you don't hit those and then end up getting these errors that aren't that helpful. It lets you run it, and then you can compare your response against those values that I just shared with you. And if you wanted, so I just also found this because this was interesting. If you need to either tweak this or make some recommendations for changing these things, it's actually inside of the Stellar Quick Start, which is also probably really tiny. Inside of local, so I'm going to be running a local network, so it's very fast. Inside of core, etc., config settings, there's this unlimited JSON. There's also a testnet JSON, which actually probably needs, oh, it was updated 3 days ago, so it's probably doing all right. You've got all of these, kind of what you just saw on the core side, the thing that they'll use to generate the different phases. Really quick, there is one value that's not included in the docs yet that caught me by surprise. And that is, I should probably look at it in the testnet one because I think it's 200 or 300 bytes. And that is the key size. Yeah, the contract data key size. So we knew that entries had a max of 65 bytes, but the keys inside the entries also have a limit, and they're very small. So that one caught me a while back. And so we should definitely put that into the docs. But there's a 200 byte limit on key names, so that's important. Okay, so that's all that. Let's get into actually running an unlimited Docker. So I have this linked to a Docker unlimited. So this is just going to run this bash script, which gets this spun up. And these spin up really quickly, so it'll be like 30 seconds, maybe 45 seconds to get Horizon, Core, RPC, Postgres, all that stuff spun up, and it'll be running underneath those unlimited limits. And then there's another script that I run called deploy, which essentially will build my contract, deploy my contract, set up some network configurations, optimize the contract, and then run an invocation that just initializes the contract with some really big keys. Like, for example, if we look at the source, I'm going to set a key that's over the limit and an entry that's over the limit. And these are not, like, the key name is more than just this. There's also like type information and version information. So just because I set 300, the key is going to be larger than 300. So I just set these values to whatever I think the testnet currently was set to for a lot of these values. But this initialize function, I need to go ahead and set those so that when I go down and do a read, I'll have something to read that's over that, right? Because I've basically built this like dummy burner contract or function, which will allow me with all of these options to basically, I want to test for an overflow on CPU. I want to test for an overflow on memory. I want to test for an overflow on the set and the get and events, so the return values, and just set all of those to max values so I can fiddle with all of those different limits. Okay, so I need to run that deploy script that I was talking about. So bun run deploy. Oop, this is also very tiny, huh? And if you've got questions as I'm going along, kind of glancing at the chat occasionally, so feel free. Okay, that deployed and it was initialized as well. So now we're free to start running our files, the ones that actually really we're considering. And this repo is what I use in the blog post that I wrote. The ones that I use in Unlimited are the 3 and the 4. The 3 basically runs each of the limits or each of those if statements from that contract. It runs them individually. So you can really observe each of those limits. Let me go ahead and run that one really quick. Run index 3. And it runs the, look at that really quick. So it loops over each of those, defaults to everything just being the void. So that's the, when you have a optional argument, void is the version that says this is optional and I am opting not to include anything. So that's the default, and then it looks at the index and will say, in fact, I don't want for index 0, I want it to not be void, I want it to be this as a U32, and on, looping over each of those, and then it performs this run function on it, which is essentially just building a basic transaction with those arguments against the run function, and then it will simulate the transaction and take the simulation and pass it to this Sorable function that or method package that I built. I'm not doing anything with TX, the transaction. It's just taking in the simulation and then returning back the response. So that's one of the reasons it's also very, very fast, is it doesn't actually have to submit any of these transactions. It just simulates them. And so we're testing for the CPU. We can see our CPU is a bit over that 1 million. So that would be a good, obviously an indication this would fail if it was actually executed on a FutureNet or testnet or anywhere that there's a limit of 100 million CPU. Everything else is more or less fine. Looks like our read bytes might be a little high. I can't remember. I think our read was, I think that's fine. Memory, here we are, over for memory, testing for that, and on for setting. You can see our write bytes are too high. Looks like our key is also too big. For the getter, read bytes are too high. Looks like our key is also too big. So it's just a really nice way with the functions that you're calling to, at a glance, observe how much you're spending on everything, which then allows you to go back and tweak your contract. You'll notice that there is min transaction bytes, and that's undefined, and then the max entry bytes are undefined. These ones you can't really get unless you build a final transaction and submit it. So this transaction bytes, there's a limit on the max size of the transaction you can send. And I'm not going to send that back unless we actually fully build the transaction and submit it to kind of prove that this was a valid transaction, and then I'd return that. And same with entry bytes. The keys are included in simulation, but the actual data that you're sending is not included in simulation. So this is, you won't have access to this unless you actually submit the transaction, and then you can look at the transaction metadata as it comes back. And included in the diagnostic events is the actual values that were set for those entry bytes, and so then you could get that. When you do that, and that's all, an example of that is in this index 4 file, where we essentially do the exact same thing, but instead of looping over, we're actually going to do this massive unholy transaction that just maxes out absolutely everything, and we'll submit it. And then we'll simulate it, but then we'll also actually submit it as well. So this one will just be one transaction, one simulation, and one transaction. So it'll take a little bit longer, not much longer, but a little bit. Not immediately returning, because it simulates it, then it sends it, and then it digests it and returns it all back. And you can see you're kind of just, yeah, you really, this is going to be a terrible contract, won't work anywhere. But we also get this transaction bytes. So this is an enormous transaction, which the way I'm making it so big for the transaction is just making an argument that is a massive buffer. So maybe don't do that. And then the entry bytes, what I'm writing is also really big. Cool. And again, one of the reasons this is really a fantastic way to do this, and maybe the only way to really be able to do this, is if this was an actual contract I was trying to invoke on a network that would error on these limit X sessions, it wouldn't tell me like, hey, just so you know, you exceeded every single one of these. It would error out one at a time. So you would see like, oh, bummer, I went too high on my CPU. And so you'd tweak your contract for CPU, and then you'd error out on memory, and then you'd error out on reads and writes. And I don't know the exact order of which one comes first, but you'd only ever get one error at a time, which that's obvious in the way it has to be. But it's not a very great way to develop contracts, to like be whack-a-moling your errors, trying to tweak this contract, getting it down, where with this perspective, you're going to be able to, like, at a glance see, okay, everything's too much. There are certain things that I definitely will need to get down first. So that might be my entry reads and writes. It might be the number of bytes. Definitely my response or my return value is going to need to be smaller. These might come down naturally, right? I only need to decrease this by 30 million, and this one's not too far off. So in the process of improving these numbers, I might naturally improve that number and never have to actually worry about that. So rather than trying to optimize for something that may or may not actually be the problem, I could address these three and maybe these two, and then this one would naturally just come down. So this is a good way to get this full spectrum picture of your contract costs as they relate to limits. And then you can go around and actually adjust them from a holistic perspective of just throwing out your whole contract that does this terrible thing and starting from scratch, as the case may be. Any questions about that? So that's, I mean, we could, and I won't, but you can kind of go back through the different ways to do it where you simulate and try and get error responses. So like, for example, I said we wouldn't do it. Here we're doing it. But I think it's kind of interesting. If we run this, so instead of doing it unlimited, we run this testnet sh. So you'll see the limits here come from testnet instead of unlimited. There's one, we'll run this 3, and then we'll run the 4 quickly. So we'll want to deploy this again in a moment. It's probably not quite ready. It's fast. It's not that fast. There we go. So that'll spin all that up. So if you were actually trying to execute, for example, this number 3, or the number 1 and number 2, you can look at those later. We won't go through those, but you'll see kind of what I mean when I'm saying that the errors are not terribly helpful. But then I think we might also be able to get a good picture on how the decoding actually works. So the events comes through, get and set come through. So this, remember, these ones are just running simulation. Oddly enough, though, of course, your simulation isn't a good indication that your transaction will succeed or fail. So in this case, these are invalid transactions, but it actually simulated just fine, which isn't terribly helpful. The other issue is CPU and memory failed because it does test against that, but it doesn't give you a terribly helpful, like the memory and the CPU both errored with the exact same error. So that's not going to be tremendously helpful. You do have these events, which I know this one's just arguments. This one, I'm just going to show a quick trick because I think this is important for anybody who doesn't know, and hopefully we're starting to spread the good word about this particular tool. But if you take your XDR and then you pipe it to Soroban lab XDR, you want to decode it, but you don't maybe know what the type is, you can do guess, and it will tell you what the type is, or give you a list of the potential types. So that's amazing. And then you can do decode type, and then you have an output JSON formatted. Oops, not output. And it will give you a nice formatted diagnostic error. So this errored on, I know this one errored, I know that this one errored on memory, but it gives me this compute, or I think this one was the CPU one, wasn't it? It gives me a compute hash SHA-256. So it doesn't tell me what really exceeded, or other than it exceeded when it was trying to execute this. But it doesn't even tell me that it was a CPU issue versus a memory issue. So hopefully that will improve with some time. Yes, the guess option is there, and it's amazing. The other one that we could try and run is this monstrosity. I'm actually curious. I don't know what will happen with this. Looks like we get simulation, I think, failed, and it just gives exceeded limit. And then this is just that argument that I passed. That's that 7,000 or 72,000 buffer. I gotta love XDR. The one that we could run really quick is one. So I do a little bit of decoding on one. Again, you get those errors. It tries. You get an error called try again later. There's this one, which is TX invalid. You get a nice. This one's helpful. This is coming from when you decode actual XGR. So let me just really quick, because I want to decode this one, because this was probably the one that maybe everybody's a little bit like, what is this diagnostic events thing you're talking about? When you actually submit, so simulation gives you decently helpful, or not really that helpful, I'm gonna be honest. Responses. So if I were to simulate another little nice trick, just really quick. If you run it rpc.simulate transaction or assemble transaction, or I guess send transaction and get transaction, if you do it without an underscore, it adds all the, builds it all together into a really nice typed interface. But sometimes, especially for logging, we want to run and just get the raw JSON response, like if I were to call it with like Postman or something. And you can do this by using the underscore. So in this particular case, now I can get both the simulation response if it's there, and then I also had a console log. We're already using the underscore here, and I can log just the response. If I get a successful simulation in assemblage, then I can go and submit it. So I'll run this again. That's the massive one. So this one only made it to simulation, and that's what that looks like. Looks like I'm already logging these, so just, yay, I did a double log. But you get these events. Those are the ones that we just decoded previously. This one looks like simulation was successful, because that's what we get with a simulation. We get this transaction response. And it also includes some events and the cost and the result response there. I want to go down to one of these ones that actually errored, which I think was the events one. Yeah. So this one, when you get a failed transaction on submission, so simulation was successful, congratulations. That's that a big event that it's trying to build. And then it fails. You get this result meta XDR. So this is the thing when you submit that has the more helpful event information. And it's also the result meta XDR or transaction metadata. This is where in my Sorabil function, I'm actually getting a ton of the information. But obviously it's way more helpful if the transaction is successful, but there is apparently in here somewhere information that tells me this. So I clear this all out and do the echo, print new lines, pipe, Sorbonne XD, lab XDR guess. This will be a transaction meta. We'll do that same thing, and we do a decode type, transaction meta, output JSON formatted. And there's quite a few of them, right? So you'll see some of the pieces of information that were even in the Sorabil thing once we get to the actual events. It looks like the only event is down here. We get exceeded limit, an error, it's a diagnostic event, and it's saying that the total event size exceeds the network config maximum. This is what it tried to use, and this is what it actually can be. Again, one of the issues with this, and again, you'd have to read the post to see exactly how I pull this off, but you can get away, I get away from this particular issue in my index 2 by essentially having a simulation that's really small, so it gets us past the issue, get the simulation footprint, and then kind of hack together a new transaction from the simulation. So I'm able to get at least a few more of these things passing. In this case, the CPU and memory don't error immediately on simulation. They get all the way through, so I can get some helpful diagnostic events from a failed submission. We still have these two unhelpful errors. However, my main issue with this, and again, this isn't really an issue with the way that it works. It's just an issue for the debuggers. It's just going to tell me what it errored out on initially. Like, I don't know how much further it could have gone than this. I just know that it errored out when it was this high. So the next thing it was going to try and do was going to be past its particular limit. I mean, this could be 100 billion, not 100 million, what it attempts to do, right? Because if you even look at that number when we were on the unlimited budget, this was like 108 or 180 or something like that million. So I don't know how badly I've exceeded my limit. I just know that this is when it limited or when it broke. So I know my CPU is going to be an issue. I just don't know to the extent. So this is again going to be a whack-a-mole situation where how much do I need to actually decrease this by in order to get underneath my actual limit, which is again one of the reasons I advocate for just test on an unlimited, blow it out of the water, and then you can scale back as necessary. Cool. So that's all that. Looks like we've got a few messages here. So I'm going to catch up really quick and then we will call it a day. Can't we just automatically decode XDR in response? I would actually really like that to happen, that if the guess would result in only one value being used, to just go ahead and use that so that we didn't have to include type, because I know what the type is, but typing out diagnostic 5 or 6 times a day is a lot, and I'm not that good at spelling. And so if it would guess, that would be awesome.
You don't even need to guess, right?
You don't? You have to include a type.
There is some echo.
What? I don't know. It'd be nice if the CLI would just not have to make me include a type and it would just guess it for me. Types contract, RPC. Oh, that's a good question. That's actually something that I'm sorry, I don't know how to pronounce that. Tupui. That's something the TypeScript binding says, right? They grab the WebAssembly, they look at the types of the contract and build a client interface for you. I think there's tools in the Stellar SDK that also do that. That can tell you like what all the types for the arguments are and stuff. You'd have to ask the AHA folks for exactly how that works, or maybe George knows, I don't. But yes, there are ways certainly that you can figure out what the contract invocations are expecting as far as types. And then you use this, where is it? Native to scval with the value and then the type. So I know these need to be U32s, and in this case, it needs to be a bytes. Would you still expect some variation with quick start and mainnet? I would assume so, yeah. I don't know exactly what it is. I would assume that it's a little bit different. But it's also a lot closer than anything else that I've used. But I don't know. There's just an interesting question that if you have the exact same fees between a quick start and an actual node, would it result in identical values? I have not tested that. That would be something worth testing. Yeah, an RPC endpoint that returns bindings. That's a good idea. Should mark that one. Spec crate, good information. Looks like most of this is just information that, yes. All right. I think that is everything. All right, fantastic. Well, I appreciate everybody hanging around. As you have questions or need anything, be sure and reach out. Look forward to catching everyone next week for the protocol meeting. We'll see you all later.